Okay, so this is going to be a demonstration of Vulnerability Advisor, a unique feature within the IBM Cloud Private platform to ensure the security of your containers and images within your cluster. I'm providing this presentation for our business partners to review how the demonstration would go. I also provide a script that they can follow at the end. I'll show that at the end of this presentation. This is using a commonly available easy access environment on IBM Cloud. We've provisioned a simple trial access that you can set up for 4 hours to longer to have a quick access to IBM Cloud Private and showcase various capabilities and features. The link to that is in the script I provide as well. Recommendation is that you give it about 30 minutes to an hour for this to be in full operational speed, and that you be on a strong network connection to get the full speed from this particular environment that we have hosted. It is a virtual machine environment that is made for broad public access, so your mileage may vary. But let's take a look then at how we access the Vulnerability Advisor utility within Cloud Private. First, I'll go over to the menu, the tools to help you get to this utility. So down here on Tools, Vulnerability Advisor, we open that. And so this organizes the namespaces for where you can locate your containers and images. So I'm going to go with, for now, for what's provided as a default option. And here we see the name of the container or image, the owner, in this case the namespace of default, when it was last scanned, whether it's a container or an image, if there are any organizational policies that were violated, number of packages that were vulnerable that we found, and any settings that we would address. I'll observe before I go into the container that the organizational policies can be affected within Manage Policies. If you want to see a longer history of the scans that took place and the history of changes that took place for a given container, you can go to Mutation Advisor. This gives you when the crawl was completed and how long it's been since the last change. If you want to go into more depth around the schedule that you can set accordingly as you want for these containers to see when it was scanned and what changes were made. Now this image was only set up recently, so it would not show prior dates having been scanned, but it gives you a calendar and per day when a change occurred. So now back to the Vulnerability Advisor, we have the list that we displayed that will give you for each container. Now I'll go in, open up a given container, and here we'll see the organizational policies that were affected, whether they passed or not, and what the violation provided. We will see the vulnerable packages that were a concern, and if there was, in this case, a buffer overflow within the curl that was provided, it will give you some instructions on what you can do to correct the matter. We see here the settings within the container. We see that there needs to be a password set appropriately for the etc. file. We will find for this lab environment, this hosted demo environment, that this shows up a lot across the different containers. Have in mind, this is not meant to be a production scale environment, so some conveniences were made to not set passwords everywhere that we might normally do to facilitate ease of provisioning and access of the environment. Normally you would want to protect the etc. Database, which contains all of the secrets and IP addresses and passwords and the like for your system. It is a common concern that people don't put passwords on there as we see if you search the internet, we will find that this tool is effective at helping you bring that to light, and this is a key place for you to get exposure to that concern and ensure that you put proper protections around a very important database like this. So when we do a risk analysis, we see a set of reports. This is a common vulnerability score system that we use to rank the major concerns, and we provide a set of common vulnerability and exposures that you would want to account for within this report. Each common vulnerability and exposure actually is has an ID and a date, and we can get into more detail around each of those. I'll describe a little bit more about this report. The attack vector is indicating how easy it is to get a hold of the environment, how well an attacker can get to it. If they need physical proximity access of it, that would be much harder for them to achieve, and that would be a lower risk concern. But if they can just get to it remotely over the network, then it is a very high vulnerability concern, and so we put that as high risk. With the attack complexity, we indicate whether certain preconditions have to be met in order for the attack to occur. If there aren't very many conditions that are required, this becomes a higher risk. Do we need certain privileges, admin rights or what have you, to get access to the environment? If no privileges have been set, and for this vector it shows that it has none, and so it's a higher risk. User interaction, does it require someone to get in the way manually along the way in order for that to occur? If no manual intervention is required, then it's a very high risk. How confidential is the information would be part of the concern. If the particular source being addressed does not have likely confidential information, we put it down as low. If the environment would be taken down, have significantly affecting the integrity or not, we would put a ranking on that. Can we completely obstruct the availability, a denial of service type attack? If that is not likely the case, then this will be low. The exploitability is, how well have we proven and known that this is likely to occur? If it's still a theory and some, hearsay and some awareness that have been raised, then we'll put it down as unproven. But if it's been well proven and well documented and repeated many times, then we'll put it down as a higher risk. If the remediation is clear that it has an obvious fix and it's provided to you, then that makes it a lower risk. And if we're very certain of the report itself, then we'll put a confidence rating on that. So we'll scroll down then to look at more of these results. We see here the risks level, the packages that are affected. If there is a Ubuntu security notice associated with that, we will highlight that, give you a link to it rather, and you can get to read that. We do have here common vulnerability and exposure link that takes you to the X-Force report. For those who don't know, IBM has a billion-dollar-plus part of the organization that is geared towards security. Very high-powered security institution that helps examine and discover all of the vulnerabilities out there in the marketplace and documents them and catalogs them, and we provide the reports and visibility to that across all of IBM's tools to improve the security of our customers' environments. So in this case, we have X-Force providing us with these common vulnerabilities to look out for. I can select this link and get the X-Force Exchange report to show up. So here is the X-Force report showing up and providing us more detail and context around how they came about this report, the concerns that we share. So similar to the scoring system, we see that as provided by X-Force. Towards the bottom, we find more information about how to remediate it and further documentation you can reference for it. X-Force is a great place to search and discover other vulnerabilities you come across. So I'll pull out of that Go back to the Vulnerability Advisor. So you have here a good sense for how we provide reports and what you'll learn about your security risks within your containers. So what I'll do now is shift over to look at going into the platform, provisioning a container, and seeing how the security vulnerability is observed for that new container as is provisioned. So going in to do that, I will first create a new namespace to help it be easier for me to locate this new instance that I've created. So I'll open up to Manage. I'll observe that as part of preparation for this demo, I did go into Helm's repositories, click Refresh to make sure that the catalog items would show up fully and accurately. So I'll go into Namespaces, create a new namespace, create that, and then now I'll go into the catalog. This catalog provides many sample resources and assets posted in GitHub. So I'm going to now look for the sample that I had planned for our instance, a Node.js sample. Very simple environment to get up and running easily for a demonstration purpose. I will scroll down for that. Alright, so I'm able to configure. Go back up here. Just do node sample for now, and I'll put in Helm Lab. Accepts terms and conditions. I will provision that. Take a moment for that to push forward. I can take a look at the Helm's release if we like. See the availability of it. We see that it has been deployed. So I will now go over to the Tools, Vulnerability Advisor, and so now I've clicked over and seen the image, and I see that it has been scanned. I edited out some time it took for this duration. I give it about a minute or so. So for your convenience, we've skipped right into seeing that the container has been scanned. There's some concerns here that we'll take a look at. Let's have a peek. We go into this sample. We see that organizational policies were fine. We see some incomplete with the vulnerability found. But most of all, I want to point out, we see that the operating system is not supported. So let's have to take a look then. What operating system was used to build this container? I go back to the original source on GitHub. I have that set aside here in a separate browser. I'll go over to it, and we'll see this Node.js sample going into the manifest. I can see that it lists just basically Linux as an operating system, not very specific there. What is required for this image to be appropriately scanned and supported? So I go into the document 4 on Knowledge Center for Vulnerability Advisor, and right off the top it starts with the set of images that are supported: Ubuntu, Alpine, Red Hat, CentOS, and the versions and the like. So this is also a good place for you to get more detail and instructions on the environment. I have this URL saved in the lab, as well as the Node.js sample link saved in the lab, so you can refer to that later, but this gives you an idea for what the concerns are for that instance. They would need to choose one of those environments to be appropriately supported, and then we can ensure better the scan results. So here we look at the container settings. Once again, I mentioned for the sake of an easy demo sample, they did not put in all of the security constraints, but otherwise it is essentially a compliant environment with little concern. So that gives you an example of roughly what it took for, again, a non-production environment for an image to be scanned right after being provisioned. I will highlight that if you wanted to see the images and their security stature directly, we could start there. Most of what we've seen so far were the vulnerabilities of containers that were in production, but you could choose before going into production to have your images scanned. You can have policies set so that if an image is not passing inspection, that the containers cannot be deployed. A lot of instructions provided on that link I showed earlier for that. But here we can see once again all of these are the container images. In this case we have one that was failed. We take a look at that instance and we'll see the similar types of reports that we had observed earlier. So essentially we've seen the Cloud Private environment, the Vulnerability Advisor tool in action, the reports that it provides, how it can scan the containers in production, and we'll see the image results that are provided, very much the same as the container. So we show here the image, highlight on it, view the scan to see what the concern was there. We see same type of report. The organizational policies were not at stake. It is a concern that this is not a supported environment, and some of the similar container settings were an issue. So that would be how we would address observing a risk for the container. That's all for this presentation. I will switch now for a moment to the lab instructions. As I mentioned, this is where you can contact me if you want a copy of these instructions, and all of the links are provided in this PDF file. Thank you for your time.